take a look at this and determine for yourself whether the nighttime effect, the after hours drift, is real or not. And from what I've been looking at, the answer is that it depends. It depends on the stock. It depends on the time. If you look at something like the indexes here with the S&P 500, definitely real. In fact, the after hours, for the most part, outpaces the buy and hold. All right, so in this video, we're going to be building a tool that will allow us to analyze the night effect. This is a theory that the stock market tends to go up in the after hours session and goes up very little in the regular session. We're going to be building this tool that you see from scratch, and we're going to be using Python and some of its libraries. Pandas is one of the big libraries we're going to use, which is going to be for data analysis and editing. And then Streamlit is going to be the user interface aspect. So this is going to be the thing you're looking at right here. So to go into what the night effect is, it's the theory that the markets tend to go up in the after hours and pre-market session. So there are basically three sessions. You have your regular session, which goes from 9:30 a.m. Eastern Time to the close at 4 p.m. Eastern Time. But then you have a pre-market and a post-market session. The pre-market session goes from 4 a.m. Eastern Time up to 9:30 a.m. Eastern Time, and then the post-market goes from 4 to 8 p.m. Eastern Standard Time. And so the theory is that the market tends to have all of its gains in the pre-market and the post-market, and it does very little in the regular session. What I've got on the screen here is a video from a couple years back on CNBC where they talk about this. This guy started an ETF based around this. The ETF ended up closing within a year of opening, so obviously it was not successful. What the reason was, I don't know. Whether it just didn't work out, or if there was too much commissions from constant trading, I don't know. This is an interesting video you can take a look at and get a better idea. One of the things I've discovered as I've been researching the markets for a number of years now is that it's very difficult to backtest, and it's just because it's so difficult to obtain data. You basically have four types of data. You have daily stock data, and that's the easiest to obtain. Then you have intraday stock data, like 1 minute candles, 5 minute candles. Those are incredibly difficult to find. And then option data for daily and intraday, also incredibly hard to find. But right here with this night effect, this is going to be fairly easy because all we need is the daily stock data, and then to analyze the night activity, we just flip it around. So if the daily stock data shows that the price at the open was 100, and then it closed at, let's say, 150, and then the next morning it opened at 200, we would know that the regular session was 100 to 150, and then we'd be able to take that 150 and insert a line for, that's the open of the night session, 150, and then we could use the open of the next session as the close of the night, 200. So it's really easy to backtest because we don't have to go out and get intraday data. Now I've got this daily stock data set up on my computer to where I download it from a brokerage every day automatically. And so when I build this code, that's what I'm going to be using. If you want to follow along, you would have to get that same sort of daily stock data. There's a couple places you can get it from. The first is you could actually go to a brokerage and plug up to their API like I've done. Can be a little complicated, but with ChatGPT and AI stuff, it's becoming easier to do. So you can check that out. Interactive Brokers, Tradier, other types of brokerages all have different APIs like that. I've also have a video here I put out a couple years ago. Goes over how to download out of Thinkorswim, which is with Charles Schwab. How you can do that easily. You can follow along there. And then I also am launching a website, which the goal is to build it out with a lot of different data. And you can come here and actually have this available on the website. If you come to SPY, and we're just going to obtain the stock data for this end of day 21st century. Okay, and then you can go ahead and purchase that and use that to follow along. All right, so I'm going to begin here. I've put some code on the right side. The right side is going to be the one that we're going to be looking at and building out, and the left is the one I've already built that I'm going to be taking from, so we're going to be going through it. So this code right here is unique to me, and it's going into my computer and getting the data that's stored on my computer. For you, if you have a CSV, what you would do is get a CSV that looks something like this, and this is what you would get if you downloaded it. And then just import that into Pandas, and there's tons of videos out there that talk about how to do that. And once you get it in, then we can start building. First thing we're going to do is we're going to put down some select boxes. And so the first one we're going to do is just to pick the ticker that we want to look at. So the way that we're going to build these select boxes, we'll say ticker selection st.sidebar.selectBox. Now there's four parameters here. The label, this is going to be what is on the box, so the little text when you go to look at it, so we want to be descriptive here. The key, this is just a unique name for the box. I just use the same thing as the label. And then we're going to have an option and an index here. So to obtain all the choices, you can see here this definition up here. Basically what we're doing is going in to the place where all of the databases are in my computer. We're obtaining all of the folders are named after the tickers. We're getting a list of those, and then we're returning that. And so in order to get those tickers, we can say choices, and then we'll just run that function. That'll return a list of them. And then in order to control the initial selection, we'll say initial selection here. Since we have string, text, choices, we don't have numbers, we're going to be doing it like this, choices.index, and this is going to return the index of whatever string is inside of these parentheses. And so we just put whatever ticker we want. It's going to go into that list, find where SPY is, and return the index number of that. So let's say it's the very first one on the list. It's going to return 0, which is what index down here wants. And I can go ahead and expand these out and show what's inside of these defs. So you can see here, this is just the initial thing connecting a SQLite. I'm actually connecting to a SQLite database, not connecting to an Excel. And then importing stock data from my computer, you can see we're just going in, finding where those SQLite databases live, connecting to it, getting all of the data from that database, and then putting it into the data variable, which we're then returning back to the function. So when we bring it in, we'll say data. Let's just go ahead and copy this. Data database location equals importing the stock from my computer. Which stock data are we importing? Whatever we choose on the ticker selection up here. This next part here, this is st.write. This will actually write stuff onto the Streamlit user interface, and this is just telling us what ticker is showing and more information about where it's coming from. All right, so down here when we run the data, you can see this is what it's in. It's inside of a list, and then all of the other things are inside tuples inside of the list. And so this makes it fairly easy to get it into Pandas. Right here, df equals pd.dataframe. We're telling it insert the data into a data frame, and then these are going to be the name of the columns. And so this very first item in the tuple is going to be the first column, the date. This is the open, high, low, close, etc. Now from this we only need the high and close data along with the date, and so the next step here is we're going to drop those unneeded columns. So when we print the data frame now, you can see that we're in a nice neat data frame. We have 3 columns, the date, the open, and the close. And on the left side you can see we have some intermittent code here. We'll add that a little later on. But for now, we're going to skip down to create data frame. And so what we have to do is we have to create 3 data frames, the one showing the regular session activity, one showing the non-regular session activity. I called it night. And then one that shows all activity, which is going to be buy and hold. Now, daily data is unique in that it already is structured to record the regular session activity. The open and the close refers to the open of the regular session and close of the regular session. And so we don't need to do anything for the regular, but we do have to make some adjustments for the night data frame and then the buy and hold data frame. The easiest one is going to be the buy and hold. All we have to do is use the prior close and replace the open with the prior close so that we get all of the activity. And then for the night, that's going to be a little more complicated where we have to flip things around where the close will be the open and the open will be the close. So because we're doing 3 different data frames, instead of writing out the code in the regular section, what we want to do is try to put it all into a def and then have it cycle through. And so you can see on the left side, that's what I had done here. We're going to use create data frame here. We're going to pass it the data frame as it exists before we do any changes on it. And then we're going to tell it one of 3 things, either day, night, or all. And based on that variable, it will run different things in the code here. So you can see right here, the if section here, night, that's only going to run this code when we're building the night data frame. So on the right side here, we're going to say def create data frame, df and session. First thing we're going to do is create a copy of the data frame. So when we do the loop the first time, it's going to change the data frame around and it'll store all those changes in df. We're doing this 3 times though, so we want a fresh copy of that data frame every single time, and this will allow us to do it. Next, we'll create a new column called prior close. And this is, again, needed for the buy and hold. All it's going to be doing is going up. So we're going to say shift 1. It's going to be going up to the row above it, pulling that close value and moving it down 1 line. Now, what do we need for the night session data frame? So if you look down here at the data frame that's printed, the close is going to be the open of the nightly session. So we don't need to shift anything as far as the open is concerned, but the close of the night is going to be the open of the day in the future. So if you look down here where we have 148, 145, and 143, the night session is going to open at 145, and then it's going to close at 143. So all we need to do is move this open value up 1 line. We'll do that by doing shift, but -1 this time. So we'll say df prior open equals the open value dot shift -1. I'll add on an if statement here, if session equals night. That way it only runs when we're creating the night data frame. And then all we need to do is just replace those values on this particular data frame. So we'll say when we're doing the night data frame, we're going to replace the open values with the close values. And then the close values will be replaced with the values we got from the prior open. Final step, sort of optional. We're just going to be dropping the prior open column because we no longer need it. This makes things a little easier to read if we print the data frame. df equals df.drop, the name of the columns, and then axis equals 1 indicates that it's a column. So this next row here, drop NAs. So we're moving the prior close. It's going to be moving the close down 1, and then the prior open is moving to open up 1. So obviously the first row of prior close and last row of prior open is going to be not a number. So if we really wanted to, we could do code that would somehow replace it. It would do maybe the open or the close on that line to put a number there. I don't particularly care. I'm just going to drop those 2 rows. That way we don't have any issues when we go to plot it. All right, so now we're ready to begin calculating the differences and the percent change. One thing we do need to do though, we need to change the open on the buy and hold column so that it's the prior close. You can see on the left side here, I did a simple if statement here in line. So we said the open is going to be prior close if session equals all, otherwise use open. We could also write that if we wanted it to be a little more verbose. We could say, do the same thing we did up here for night. So if session equals all, we could say df open equals df prior close. And then we'll come down here and do the calculations. And when we go to do df, so we're going to create a column here called diff. This stands for difference, and we're just going to be getting the difference between that close and the open. So it'll be df close minus df open, and now we've replaced the open with the values that we need. So for when we're doing all, we've replaced open with the prior close. So it's actually, in that situation, the close minus the prior close, and then same thing up here for night. We switched them around. So it's not necessarily the open of the regular session. It's just we've changed this around as needed so that it's only one line here. And then we'll create a column called perc, which stands for percent, and it will be the difference that we calculated divided by the open. All right, so we've gotten the percentage for each row, and that's going to be in decimal form there. So if 2% would be represented as 0.02 in the perc column. Now what we need to do is calculate the running total of those percentages. And so if we come over to Excel, I've set this up here. Now this is a little different than what's in the Visual Studio Code. Let's go down here and do this, 0.02, 0.03, 0.04. We'll show both ways here. So if we had percentages in regular percent form, what we would have to do is we would first have to add 1 and then divide that percentage by 100 to get it into decimal form. Down here, since it's already in decimal form, what we can do is we just need to do 1 plus 0.02. Now this would be step 1. Step 2 then would be to do cumulative product, which would be multiplying the previous times the current. So right here, we're going to start with 1 times by 1.02. Next one, 1.02 times it by 1.03, and etc. So we do the same thing down here, and I'm not going to fill that out, but that would be the same numbers. And then the third step here would be reversing what we did over here in step 1. So in step 1, we added 1 and divided by 100. Now we would subtract 1 and times 100. So we're going to do the same process over in Python. What we'll do here is we'll say calculating running percentage. We'll start by creating a new column called run perc. And this will be, we'll start with step 1. So we'll say we're going to take the percentage. Now it's already in decimal form, so all we need to do is add 1 to it. The second step, we'll override the run perc column, and we'll do run perc, and then to have it do that multiplication, we can do dot comprod at the end. And then the third step would be, again, overriding comperc and getting it back to percentage form so we can see the actual percentage. And what we'll do is say run perc minus 1 and then times it by 100. So we can print this to see what's going on. We'll return the data frame, and then we'll come up here and grab the name of the function, come down here to the code, paste it in. On the left side, we'll give a name for the data frame that we want. We're going to do the regular data frame. So I'm going to call the regular one data frame regular. Creating regular data frame. And then inside the function here, we'll pass it the parameters of df, and then we'll say day, I believe, to indicate, yeah, that is the regular session. Down here, we'll go ahead and say print df regular. And down here in the terminal, we can see we now have a new column called run perk, and we can see we have the running percentage total all the way to the end. So what we're going to be also calculating here, the running difference, and so this is going to be just the same concept, the difference of each candle as we go along. And then we're also going to be calculating running absolute difference, and so the difference between these two, let's say up here with the difference, let's say the stock went up $100 and then declined $100, that would be 0. With absolute, it would be 200. You just remove the negatives off of everything. And so what this is going to give us, the difference is going to help us see it's going to be a better way to look at the breakout between regular and nighttime. And then absolute can be thought of as the volatility, which section is going to be more volatile. To get those values, fairly simple. We just do diff.comSum. Same concept up here, except instead of multiplying, we're just adding. And then down here, it's going to be the same thing, except we're going to do .abs, standing for absolute value. We're also going to be counting the number of positive candles and doing a percentage there. So the first line here, I'll sort of explain what this is. We're creating a new column. I'm just going to call it pos, for short for positive. The first thing we're going to do is say, what do we want to measure? Well, we're going to use the difference column, and that's going to be whenever it's positive, it's going to be positive. Whenever it's negative, it's going to be negative. We could also use percentage column. Whenever it's greater than 0, that's what we want to count. And so what that's going to return is true false. It's going to return a single column looking like this, right? If it's greater than, if it's a positive, it's going to be true. If it's not positive, it's going to be false. Now, in order to get the count, we have to change that to a 1 and a 0. So we're going to add .asType int. That's going to change it to that 1 and 0. And then we'll chain it with comSum. So I've put sum and comSum here to show the difference between these two. So with just generic sum, what would happen is it's going to add up all of these true values. It's going to count how many were true, 7 in this instance, and then it's going to return 7 for every single row in the data. With comSum, we get that rolling count, so it's not going to add up everything and then return the final number. It's going to add it up as it goes along. So you can use either one based on what you're trying to accomplish. If you have something where you want something to add everything up and then return that final value to every single row in the data frame, you can use sum. If you wanted to have a rolling one, which I think is going to be more common, you would use comSum. And then the same thing would happen for the prod and the comprod, except it would be multiplication instead of addition. So back over here, we'll say asType int, and then comSum. So that gives us the count of the number of positive ones, but we want to divide it and get a percentage based on, so if let's say we have 5 rows that are positive and we're on row 10, I'm going to want to see 50%. I don't want to see just 5. And so to do that, what we'll do is we'll override that positive column. We'll start with the count there. So we'll say df_pos, which would be that 5 value. And then to get the total number of rows, the row number that we're at, we'll say df.index. Now the index for row 1 starts at 0, so it's always 1 behind, so we'll add a 1 there. and that'll give us 0.5. In order to get it to 50%, we'll say df pos, and then times it by 100. All right, so we now have this set up to run, and so down here we'll create 3 data frames. We'll say df night equals create data frame df, we'll pass it night, and then we'll do the same thing for, I'll call this ph. We'll say all there. So next we're going to move it into a dictionary in order to get it to plot on the line graph. And so this is the setup over here that I'll use. What we're going to say is, let's grab this comment here. We're going to give it a name, line graph data. You can choose to call it whatever you think's best. And then it'll have a key value here. So the key value, regular, night, buy and hold. And then the values here will be this right here. So we're going to be referring to the data frame and then adding whatever columns we want to bring over into the line graph. So I'm going to end up having a drop down box where we can see the percentage, the difference, the absolute difference, and the positive percentage. So we're going to bring all 4 of those over. Next, we'll build a line chart. I'll come up here to the function section, create a new function saying def build line chart. First thing we need to do is activate the line graph. So we'll do that by, some people in the documentation say fig ax equals plt.subplots. And then once you do that, you'll have to bring in the matplotlib libraries up here. I'm bringing in those too. What I've been doing though is just saying canvas charts, just so that it's more descriptive and easier for me to understand. I haven't had any problems yet. So, and then on fig size here, we'll just say 10.4 there. All right, so the next part is one of the more difficult parts where we're actually pulling out the data needed and plotting the lines. So if we run line graph data, what you'll get here is this dictionary, and it has a key and then the value. In this situation, we haven't put a number in there. It's actually a full data frame that we have in here. So what we need to do is just cycle through this dictionary, and with every cycle, we're going to be accessing a data frame. And so up here for key value in line graph data.items, every single for loop, it's going to have 2 values. One is going to be the key, and so the first loop is the key is going to equal regular, and then the value is actually going to equal a full data frame. And so you can see right here what I've done is on this value, all we do is just give it the name of the column that we want, and it's going to be based on the drop down that we have. So let's go down to the drop down section here. I'll bring this one in. You can see this uses the same exact setup we went through earlier. We've listed out the choices, except instead of doing just this code here, we actually hard coded in a list of values here. So these are going to be the 4 different choices we have to choose from. Same thing here. We're going to default to percentages. So I'll go ahead and copy this over here and put this under the select boxes section. Let's see, drop down boxes. So the first thing we're going to need to do, we're going to come down here and convert date to date time. So when you bring in a date into Pandas, in my experience, it's been an object. There's certain different things you can do to get it to be a date time, and one of those is this right here, pd.toDateTime. So we're just telling it on the date column, we want to change it to a date time. So we'll come down where we had the drop, and we'll insert that. And that will allow us to add in some boxes later to filter, but for now we'll just leave that like that. And we'll come up where we do this, and so I've changed this around here, x-axis. Now that it's already in date time, we can just do data frame, and probably the better way to think about this would be df, right? I don't want to override the df since we used that variable earlier, but that would be the easiest way to think about it. Data frame, date column. And then for the y-axis here, we're simply saying use the column based on this dropdown. So for difference, we're using run diff, absolute difference, run abs diff, positive, it's going to be POS, and then any other, which is we only have one other, is going to be run perk. The next step is plotting these. So we're going to say chart.plot, x-axis. This is a little weird in that it doesn't have parameters as far as I can tell. Like, sort of for me, I like to think about it as x equals y equals, be real descriptive. But from what I can tell with chart.plot, it actually doesn't allow you to do parameters. So you just have to enter whatever the name of it is. We know x-axis and y-axis are the names, and so we're going to put those as the first two parameters there. And then the third parameter is going to be label, and we're going to give that the value of key. So that's going to be this right here. It'll tell us as we cycle through, the first one will be regular, the second one will be night, and the third one will be all. And so that'll tell us there on the legend. Let's see, it's running, yeah, right here, regular, night, and then buy and hold is going to be the other one. Let's see, yeah, we can change those right down here in the dictionary, regular, night, buy and hold. A lot of this next code is pretty straightforward. It's just sort of miscellaneous things. We're turning on a grid on the line graph. We're changing the color. Right here, formatting the x-axis. This is going to make it to where it rotates 30 degrees, and then it only shows every 12 periods. So you see right here, April 2023, April 2024, April 2025. And then it's sort of tilted 30 degrees there. It makes it easy to read. X label here, we're telling it just to name down here, date, right down there. The left side is going to be the Y axis, and you can see right here, this is a little more complicated. We've said we want it to just say percent if it's percentage or positive percent, otherwise show a difference as a dollar amount. Title, I've said title here. This turns on the legend, so we'll copy all of this over into this right here. Now, this is going to be outside of the loop, because once it's gone through and gotten all the numbers and plotted the lines, then it'll have all the data. So outside the for loop here, one other little oversight I had here, we bring in the line graph data. In order to do that, we have to pass it as a parameter up here. So we'll say line graph data right there. Now this next part down here, set minimum y-axis value for positive percent charts. The issue is that when you go to that positive percent box, you can see initially it's going to have a lot of volatility, because, like, for instance, line 1, if it's positive, it's going to be 1 out of 1. It's going to be 100%. If it's not positive, it's going to be 0%. So we're going to have a lot of unnecessary volatility initially. We really just want to see sort of all the way to the far right where that positive percentage ends. So what we've done is we've limited it to 40 and 60%. That way it's not making this too small. What we've said here is top and bottom, 60 if view selection is positive percent, and then when it's not positive percent, we don't want to have any sort of restrictions on the y-axis, so we've just said none. And then the final piece of code here, we're just going to be plotting it to Streamlit. So we'll come down here, paste that in. Come back up here, we'll grab the name of the function, build line chart, come down here, and we'll paste that in, and we'll pass it line graph data. So this takes the items we stored in the dictionary and passes that dictionary to the function up here so that it can use it right there in the for loop. All right, so we can go ahead and run this in Streamlit just to see. I got an error message here. So what we'll do, the issue here is need to describe fig size here. So I'll say fig size. Come back over here, F5. All right, so you can see we've got this plotted out here, and so we can already begin to see some of the results. And so you can see the SPY here is plotting, and incredible results there. That it definitely confirms this after hours effect. Almost all of the total returns for the SPY being the ETF for the S&P 500, one of them, but definitely the most popular one. It almost entirely made up the entire buy and hold. The regular session was almost at zero. This is going back to the earliest I have in the data. I start the data at January 1st, 2000. It goes all the way through. And so we can change this around here. The difference, we can see the dollar difference. So $100 gained on the regular session, 400 on the night session. That made up the 500 on the SPY. Absolute difference here. You can see, and this was the odd thing, because the night definitely does better, but remember, this shows sort of your volatility, and you can see the regular session had more of a price fluctuation than the nighttime. So sort of opposite of what the general consensus is. A lot of people say there's a lot of volatility at the nighttime. Not the case. According to this, it is the most volatility is in the regular session. So now what we're going to do here, we want to add a filter so that we can sort of filter based on time periods. So instead of looking at all 25 years, we want to look at maybe just the last 5 years. So what we'll do is we'll come in here. We'll start with the select boxes. We're going to add a couple of date input boxes. You can see how I've got these laid out here. 4 values, the label and the key, same thing as up here with the select boxes, just give it a name. The minimum value, this is going to be what we want the earliest to be. So my data goes back to the beginning of 2000, so I've just said the date of 2000. It's going to be year, month, and day. On the end date selection, the value, this is going to be what it starts at. I've said date.today because we want it to start by default as whatever the most recent day is. And then up here on the start date, I've said start it 3 years before today. So when it opens up, it'll default to show us the last 3 years, and then we can change it around as needed. So I'll come down to the section right here. I'll paste this in. Now it will need another library of date. So we come up to the library section here and just bring all this in. If you don't have this installed on your computer, you'll still get an error. So what you'll need to do is open up command prompt pip3 install. And there's a lot of videos out there that can tell you exactly what the verbiage is to download it to your computer, but pretty easy process. All right, so now we're going to come back to the bottom of the code here, the main part, and you can see right here where we had the change to date time, we have the filter based on the time inputs. So this is just filtering based on start date and end date. So that's what this is, and then we have reset index at the back here. So when we chop up a data frame, it'll keep the index value. So the first row is going to be 0, the second row is going to be 1. If you chop off the first couple of years, your index will be at 700, 701, 702. So we're just resetting that, and then drop equals true removes it automatically adds the index column as a column in the data frame, and so we're saying we don't want that. This final piece of the puzzle here sorts values earliest to latest. It already is sorting earliest to latest, but I did notice there was an issue on some of them where it got out of order for whatever reason. So this right here will ensure that everything's in order from earliest to latest. All right, we can come over here and hit F5 to reload this. And you can see it's only showing us the last 3 years now. And we can change this around as needed. So let's go back to 2015. You can see 2015 data. So it allows us to get a granular look. There's 5 years from 2015 to 2020. So added functionality there. And then to finalize this, I'm just going to print the data frame to the Streamlit page so that we can actually see the numbers. If you look over here, right here at the bottom, we can see the numbers there. So what we'll do there is we're going to add another select box first. So again, right here, similar process as we did before. I'm just going to paste this. And we've set 2, so that means it's going to return all by default, and then we can change it around as needed. And then down here, just an if statement, so it says if that selection box is all, print the buy and hold data frame. If it's regular, do the regular data frame, and if it's night, do the night data frame. And then st.write, this just tells us what database we're looking at, and then st.dataframe then actually prints the data frame to Streamlit. So the final step here, if we want to clean up these data frames a little bit before we print, we can. We don't need to have the prior close column, and we can also reformat this date column to show it in like month, day, and year. We want to do this right between this because the data frame at this point no longer exists. It's now either DF regular, DF night, or DF BH. So instead of doing all 3 of those, we can just use, right here we've assigned it selected data frame. So if we come down here, we'll say selected data frame equals selected data frame dot drop. Tell it to drop the prior close column, and then axis equals 1. And then to clean up the date, we'll do this right here. I'll change this to date. df date equals df date.dt.strftime, and then this is the thing we have to pass it in order to get it into the correct format. All right, and one error here. Again, we want to change that df to selected data frame. All right, and so that's it. We've gotten the little tool built here. So now you can play around with it and sort of take a look at this and determine for yourself whether the nighttime effect, the after hours drift, is real or not. And from what I've been looking at, the answer is that it depends. It depends on the stock. It depends on the time. If you look at something like the indexes here with the S&P 500, definitely real. In fact, the after hours, for the most part, outpaces the buy and hold for the percentage. That's the S&P 500. If you come here to the DIA, which is the Dow Jones Industrial, we see a similar thing. That video that I referenced earlier, they talk about the Russell, which are the smaller ones that they say it's there. I don't think I have that. I might. What is this? IWB. Yeah, I think this is a index too. IWB. So it's definitely true on the indexes. Now, when you come to the stocks, it's a little bit of a different story. We can do Apple here. You can see Apple, complete opposite story here. The regular session is actually just as much as the buy and hold. And if you, over the last 25 years, had run the nighttime drift strategy on Apple, you would have lost money. We can come to something like Netflix, and then we see on hybrid situation, the nighttime was a little bit better, but definitely wasn't as good as just buy and hold. And then we can come back to SPY and sort of change the time around. So we can see over the long term, the SPY was definitely beneficial, but we could look at, last 5 years. Well, over the last 5 years, the nighttime, just doing the nighttime would have not been as good as the buy and hold. The regular was, let's see, the difference was, so the regular session made a little bit like $120 over the last 5 years. So the answer is it depends, really. And I think that's probably why once they started this ETF, one of the reasons why they ended up closing it down, because it just depends. It depends on the time period. It depends on the stock. Some of them nighttime. One thing I would say is the smaller ones look like they have that nighttime effect. So if we come down to maybe O, which is like a realty company, you see that nighttime effect there pretty strongly. WP Carey, which is another stock that's small, pays out a dividend. Also see the nighttime effect. But then you go to the bigger ones, and it's not always there. So anyway, that's going to be the conclusion of this coding.